Each problem in section 4.4 is a word problem. And for each of the problems, I've drawn a picture that models the function that's given in the question just to help my explanations. And we're not going to really do graphing in this section, but it's going to make it a lot easier to understand what's going on if I have a visual representation of the function. I'm going to start with problem 2. And as I read problem 2, it just talks about an object being fired vertically into the air, and it says its height, h in feet, after t seconds is given by the equation. So the left-hand side of the equation represents the height of the object in feet, and the right side is a formula, and the variable in it, t, represents the time in seconds. I went ahead and sketched a graph of this, and it's a parabola that opens upside down, and I labeled just a few key points. The first point I labeled is the point 0, 0, and because to the right of the equal sign the variable is t, the x position of my point is time, and the time is in seconds. So the first point, the x coordinate represents 0 seconds. The y coordinate is, the y is kind of like the h here, and that's the height in feet. So at 0 seconds, the object is at 0 feet high. It travels a parabolic path, and it gets to its maximum height at 3 seconds. And that height is 144 feet. Once it gets to its maximum height, it continues its parabolic path, but in a downward direction. And it gets to this point 6, 0, which means at 6 seconds, it's at 0 feet again. The x-axis is more or less working like the ground. So, if I want to answer these questions without doing any algebra, if I had this graph, I should be able to answer the questions. How long does it take for the ball to hit the ground? The ball starts at 0 feet. After 3 seconds, it gets up to 144 feet. And then at 6 seconds, its height is 0 feet again. The answer to part A, how long does it take to hit the ground? It's going to be 6 seconds. Of course, you won't have the graph in front of you. I'll show you how to get the answer without having a picture in front of you. When does the ball reach its maximum height? It reaches its maximum height at 3 seconds. And what is its maximum height? 144 feet. None of this is terribly hard in terms of algebra, but I could, but it's algebra, so it's got to be something. So for part A, how long does it take for the ball to hit the ground, or how far does really this should probably say object, or if this said ball, then this is better. So I'll change that. How long does it take for the ball to hit the ground? To do that, I'm going to make the height 0 feet because the ground has a height of 0 feet. So to do part A, I'm just going to go 0 equals negative 16t squared plus 96t. Every problem that we're going to do, if I want to solve it by factoring, meaning it doesn't have an ugly decimal answer, the coefficient of the squared term is going to be a common factor. And in order to solve this by factoring, it's best to pull out the common factor. The common factor I'm going to pull out a negative sign because the first term is negative. Each of the problems that we're going to factor today, the leading coefficient is going to be a common factor. So the 16 is going to be a common factor. And both terms have a t, so I'll factor out a t. To figure out what goes inside the parentheses, the negative 16 I pulled out, so the coefficient of the first term is going to be a 1 because I factored out its coefficient perfectly. The t squared, I'm going to change to a t because I factored out a t. After the t, I factored out a negative, so I'm going to switch my sign. And the number that I'm going to get, I'll take 96 and divide it by 16. The 96, that was the coefficient of the t, divided by the 16 that I factored out. I've already accounted for the signs, and I'll get a minus 6. Now that I have this factored, I can set each factor equal to 0. the factor of negative 16t, I would divide both sides by negative 16. And this tells me that it starts on the ground. This isn't how long it takes to hit the ground. And then this factor, adding 6 to both sides, gives me the 6 seconds it takes to hit the ground. Done with part A the best I can. For part B, if I didn't have the graph to know that it takes 3 seconds to get to its maximum height, I should at least understand that this thing would follow a parabolic path, and a parabola opens down because of the negative in front of the square term, which makes the vertex a maximum point. So even without having a picture, I should be able to reason in my head that the x-coordinate of the vertex is where the maximum is. But I mean, if you've never done this kind of problem, to reason that out would be ridiculous. But I'm telling you it at least so you'll know for the future. So I'm going to find the x-coordinate of the vertex to get the time that it gets its maximum height. And to get the x-coordinate of the vertex, I'm going to use the formula negative b over 2a. And in this problem, the a is the number in front of the square term, which is negative 16. The b is the number in front of the first power term, which is 96. So I'm going to do negative b, which is negative 96, over 2a, which is 2 times negative 16. This is going to give me negative 96 over negative 32. And that's going to be the 3 seconds where the object reaches, or the ball reaches its maximum height. Lastly, when does it reach its maximum height? Well, the answer is 144 feet. If I know a time, I can get the corresponding height by plugging that number in for time, because plugging numbers in for times gives me height. So the height is going to be negative 16 times 3 seconds squared plus 96 times 3 seconds. So negative 16 times 3 seconds squared plus 96 times 3 seconds gives me the maximum height of 144 feet. That's everything for question 2. That's an easy question compared to what we have coming up. Your problem 1 is basically the same question, other than you get a little bit uglier time for the when it reaches maximum height. It's 2.5 seconds. That shouldn't be that bad if you're using your calculator. If it is, come visit me and I'll try to do it for you. 3 and 4 are a little bit messier, are a lot of it messier. And so let me try to solve this in a clever way, the best I can. So 3 and 4 are twins to each other. I'm going to do 4 and leave you 3. So again, I have a similar situation. A ball shot into the air, its height in meters this time as opposed to feet, after t seconds is given by this formula. So the t's stand for seconds, the h stands for the height in meters. This plus 5 means it doesn't start on the ground, it starts at 5 meters in the air, which is maybe like on a little platform, because that's like 15 feet. So here's the parabolic path. The object at 0 seconds is 5 meters in the air, so maybe like on a little platform. It goes up, up, and up, and up. At 1 second, it's at 37 meters. At 1.5 seconds, it's at 41 meters, which is its maximum height. Starts going back down. At 2 seconds, it's at 37 meters again. And then it goes down, 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 down. And at 3.1 seconds, it's at 0 meters. So these are times in seconds, and these are heights in meters. Should be able to answer all the questions from my graph and then confirm them with some algebra. You're not going to be given the graph on the test. So at what times will the ball have a height of 37 meters? At 1 and 2 seconds. So the answer here is at 1 second and at 2 seconds. I don't know that I wrote that the best, but at 1 and 2 seconds, it will have a height of 37 meters. How long will it take to land? 3.1 seconds. The fact that that answers a decimal is not my friend. It means I can't solve by factoring. And then what's the maximum height it reaches? 41 meters. So if I have a picture, these answers are easy. You're not going to get a picture provided to you, so you're going to do the algebra. In order to figure out the answer to when the height is 37 meters, I need to take the 37 meters and plug it in for the height. So I'm going to go 37 equals negative 16 t squared plus 48t plus 5. I'm going to minus 37 and get 0 equals minus 16t squared plus 48t minus 32. I can solve this by factoring. I'm very comfortable factoring. A lot of my college algebra students aren't very good at factoring. This equation has a square and it's equal to 0. I can use the quadratic equation, and that's what I'm going to attempt to do. I'm going to use a equal to negative 16, b equal to 48, c equal to negative 32 in the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And depending on the technology I have, it's going to be ugly or easy. The formula that I'm going to need is time equals to negative, and then for b, 48, plus or minus the square root, and then b squared is going to be 48 squared, minus 4 from the formula, times a, which is negative 16, times c, which is negative 32, all over 2a, which is 2 times negative 16. If I'm using my old-fashioned calculator, I would try to enter this all at once, but I'd mess up. So let me get the underside of the square root down to a single number. Underside the square root is 48 squared minus 4 times negative 16 times negative 32. Under the square root, you get 256. So this would give me t equals negative 48 plus or minus the square root of 256. And I don't need my calculator for the denominator. It's just negative 32. So on my old-fashioned calculator, I can enter this. I'm going to do this on my old-fashioned calculator. I'll do parentheses for the numerator, negative 48. I'm going to do the plus first. I'm going to do a square root symbol. And my old calculator wants the square root, the radicand, to be in a parentheses. It also needs the numerator to be in a parentheses. So I'm going to enter that on my old calculator. Then I'm going to type divided by negative 32. This will give me probably the 1 second answer. So parentheses, negative 48 plus second and x squared for square root, and then 256, double right parentheses, divided by negative 32. There's the 1 second. Hit my second button followed by the enter key. So second followed by the enter key. That'll allow me to backwards change the plus to the minus by the plus sign, hit equals, and there's the 2 seconds. On my fancier calculator, I would do this. I don't even need, I can enter this right here. My fancier calculator, math button. After math button, bounce over to fraction and hit equals. No, clear this. Math button, over to fraction and hit equals. Now I'm going to go negative 48 plus second and x squared for square root, and then parentheses 48 squared minus 4 parentheses negative in the bottom row of the calculator 16 parentheses negative bottom row of the calculator 32 all over 2 times parentheses negative 16. I don't need to do any startup work because it's so easy to enter. There gives me the 1. Hit my second and enter button, back arrow, do my best to get up to this plus between the square root and the 48, change it to the minus by the plus sign, and hit equals and get my 2 seconds. Both calculators can get the answer. This one's way better for that kind of computation. For part B, I'm bound to this ugly quadratic formula again, but in this case, how long will it take to land? It lands when the height is 0. So I'm going to plug 0 in for the height and do negative 16t squared plus 48 t plus 5 on the right side. Because of the decimal, I can't factor this, so I'm bound to the quadratic formula where the a is negative 16, the b is positive 48, the c is positive 5, and this is going to give me the time equals to negative b, which is negative 48, plus or minus the square root of b squared, which is 48 squared, minus 4 times negative 16 times 5 over 2 times negative 16. For my old calculator, I gotta get this working better for me. So under the square root, I get 48 squared minus 4 times negative 16 times 5. Under the square root, I get 2624 if I did this right. So this is going to be negative 48 plus or minus the square root of 2624. The denominator is negative 32. So on this calculator, I'm going to go negative 48, preceded by parentheses, plus square root 2624, close the parentheses for the square root, close the parentheses for the numerator, divided by negative 32. Let me make sure I have the right number that I'm working with here. So 48 squared minus 4 times negative 16 times 5 feels good. So parentheses, negative 48 plus second square root, parentheses, oops, yep, that's too many parentheses, 2624, double parentheses, divided by negative 32. That gives me this time right here. This is a negative time, this negative 0.10. This thing didn't start on the ground, it started in the air, and this doesn't make sense. Negative time isn't acceptable. I'm going to ignore that solution because we don't have negative time, doesn't make sense here. Now I'm going to hit second and enter, back up, type a minus, and hit enter, and get that 3.1 seconds. It says to round to 2 decimals. I could write 3.10 seconds if I care to. On this calculator, I could just enter this. On this calculator, clear, type my math key, go over to where it says fraction and hit equals, and then it's negative 48 minus, I'll do the minus because it has the answer, second square root, parentheses, 48 squared, minus 4 parentheses, negative 16 parentheses 5, don't need any more parentheses, over 2 times negative 16. Gives me that 3.1 seconds. So much easier on the newer technology. For part C, I can't get the maximum height without knowing the time that it gets its maximum height. It's only one question, but I can't get there directly. First, I need to get the time where it reaches its maximum height, then I can get the maximum height. So first I'm going to get this. It's not asked for, but I need it. The time to get the maximum height, I can find by using the negative b over 2a formula, where the a and b are the same. B is 48, so I'm going to get negative 48. A is negative 16. This is over 2 times negative 16. This gives me negative 48 over negative 32, and apparently that comes out to 1.5. I know the two negatives cancel to be a positive, so I can just do 48 divided by 32, and I get 1.5 seconds. Not the answer, but it's the tool to get the answer. Now I'm going to plug 1.5 in for the time. I'll do the height is negative 16 times 1.5 squared plus 48 times 1.5 plus 5, and that should give me the 41 meters. So it doesn't matter which calculator I use now, they both work the same. So negative 16 times 1.5 squared plus 48 times 1.5 plus 5, and that tells me I can't type. That's supposed to be a point and not a minus. And there's the 41 meters. Very calculator heavy. That's as ugly as it gets in this section. Far and away there isn't anything close to that kind of grunge. Your problem 3 is exactly the same. I just changed the numbers. For part A, at what times does it have a height of 118 meters? I see the answers of 1 in 7 seconds. And when you go to do part A, you're going to set the height, desired height of 118 equal to the function. Set it equal to 0. If you're awesome at factoring, because the answers are nice, you can factor. Most students kind of shy away from factoring when the numbers get this big. I'm missing the t there. Pull out the quadratic formula to get it. For part B, so this would be part A, for part B, you're setting the equation equal to 0. Quadratic formula again because it has a decimal answer. And for part C, it's going to go in phases. For part C, I'm going to find the time that it reaches its maximum height by doing negative b over 2a. Apparently that's going to give me 4 seconds. And then I'm going to plug 4 in for the t's to get the height that I need. So that's just a skeleton of what you need to do. Just in case you didn't know where to get started, you can refer to this. It'll help you get started. It's not doing the algebra for you, though. Now they get a little bit easier. 6. A diver dives off a cliff into water that is 240, should be 144 feet below. A diver jumps off a cliff into water that's 144 feet below. The diver's height after t seconds is given by this formula. How long will the dive last? So here's the diver. The diver at 0 seconds is standing on a platform that's 144 feet high. I would never, ever, ever for any amount of money jump from that. And the diver's path will look something like this. It looks probably more straight down than this. But anyways, this formula was supposed to give me its height. I'm worried about when it hits the surface. That's when its dive ends. And this point says at 3 seconds, the height is 0 feet again. So the answer is going to be 3 seconds. At 0 seconds before, right the instant before the diver dives, she or he is at 144 feet, and then at 3 seconds the dive is over. So I'm just trying to find the time that gives a height of 0, and this is easy. So I'm going to put 0 in for the height and solve for the time, because the dive ends when the diver hits the water when the height is 0 feet. That's how we're defining the end of it anyways. So I'm going to solve this. 0 equals negative 16t squared plus 144. I'm going to add 16t squared to both sides. This is so much nicer to solve. When I add 16t squared to both sides, I get 16t squared equals to 144. Then I'm going to divide both sides by 16 and get t squared equals 144 over 16. I imagine that fraction reduces. It might even come out perfectly. I can do the algebra in my head quicker if I do the next step before simplifying that fraction. To solve this problem, I'm going to plus or minus square root. And I'm going to get 2 answers. I'm going to get negative 3, which fits the parabola, but doesn't fit this situation. You don't have negative time. I'm just trying to get the answer of 3 seconds. When I square root t squared, I get t. When I square root the fraction, I square root the numerator. The square root of 144 is 12. I square root the denominator. The square root of 16 is 4. So I get plus or minus 12 over 4, which is plus or minus 3. Technically, it says the answers are 3 seconds and negative 3 seconds. But of course, negative time doesn't make sense in terms of this context. So I throw the negative out and write the answer. The diver's dive lasts for 3 seconds. And that's it for number 6. Your number 5 is essentially the same question, except instead of a diver jumping, a baby's dropping a bottle and it's just going to fall down. We'll say it's going to follow this path. It's probably more severely straight down than that. But anyways, after how many seconds will the bottle hit the ground? The ground has a height of 0 feet. To solve problem 5, we're going to plug 0 in for the height and solve for t. Exactly the same way that I did by isolating the square, dividing, and square rooting. The answer should be 2 seconds. And your problem 7, same style of problem. It's essentially exactly the problem that I just did in number 6. So that should have an answer of 2.5 seconds for what it's worth. So you should be able to do those problems real easy. How long does the dive last? You just set the function equal to 0. Isolate the variable to make it positive. Divide by 16. Square root. I really don't need the plus or minus square root, specifically because the negative time won't make sense. And you'll get time is square root of 100, which is 10, over the square root of 16, which is 4. I wrote my answer as a decimal, which just made sense to me, rather than saying 5/2 seconds, which was that fraction would simplify to. I'd like to do a couple more problems. I'm short on time, but let's try to do one more. So problem 8 talks about a chain store manager that's been told by the main office that the profit that we can make is based on the number of clerks. You know, maybe it's like the Home Depot. If you've got enough people working, they can help the clients and upsell them, get them to buy some stuff. But at some point, if you have too many people working, then some people aren't maybe being productive, helping in their sales, and you're just paying their salary. They're not adding to the sales. There's lots of scenarios here that we probably can walk through. But anyways, this function that probably has nothing to do with reality tells me, based on the number of workers, what the profit would be for a day at some particular store. And again, I make the numbers maybe smaller than they might need to be in actuality to make the computations not so ugly, even though they can get ugly with small numbers, like we learned in problem 3. So this function right here, every point on it gives me some information. This point 0, 0 says if I have 0 workers, my profit will be 0. I won't make a penny. Similarly, this point right here, the point 12, 0, means if I have 12 workers, well, I'm going to be paying a lot of people for not producing much, and I'm going to have a 0 profit as well. There's the sweet spot for this company. At 6 workers, the profit's going to be $900. So each point on this, the X stands for the number of workers, or the number of clerks. I don't know why I wrote clerks. I probably lifted this from another text because I wouldn't use the word clerk. But if you had 6 clerks working, the X's stand for the number of workers, the P stands for the profit. The X's are the number of workers, the Y's are the profit. So the number of workers that are going to be optimal is 6. The daily profit that this small company could earn is $900. How do I get this? So easy. This is just a parabola, and the optimal answer is at the vertex of the parabola. The x-coordinate of the vertex is the optimal number of workers. The y-coordinate of the vertex is the maximum possible profit. To find the x-coordinate of the vertex, I use the negative b over 2a formula that we've used a couple of times, where a is the number in front of the squared term, negative 25. B is the number in front of the first power term, 300. So negative b is going to be negative 300 over 2a, which is 2 times negative 25. This is going to be negative 300 over negative 50. And that's going to give me the 6 workers that will yield the maximum profit. How do I get the profit once I know the number of workers? Simply plug the number in for x into the profit equation. the profit with 6 workers is negative 25 times 6 squared plus 300 times 6. I'm going to trust that I have this right. I could do this on my calculator. But that's just button pressing, and that's not very sexy button pressing. So I'm just going to say the $900 is probably right. Your problem 9 is the clone of this. So it's a slightly different situation, but structurally the problem's going to be the same. So it says a total profit, there's my profit equation, for a company to manufacture and sell X items is given by this. So sometimes, if you have very high production, your costs run up because you're paying overtime. So you just can't sell infinitely many items. You might have capacity at your shop plus overtime issues. There's an optimal quantity to produce to make the maximum profit. So in this particular problem, the X stands for the number of units of whatever this product is that the company makes, and the P side stands for the weekly profit. And again, I keep the numbers smallish to keep the math easy. How do I figure out this? Well, I have a picture right here. You can see the profit right here. The Y's are the profit. The maximum profit is $625. It occurs when there's 25 workers. So for part A, the number occurs when there's 25 units sold. So for part A, it's going to be 25 units, and you have to figure out how to get that using the negative B over 2A formula. And for part B, the weekly profit is $625. You'll solve it just like I solved the last problem. I'm going to go ahead and pause the video. We'll move on to a part 2. And the part 2 shouldn't be that long, but we have some regression to do in there, so it's more button pressing.